Hi there, in this video we're going to have a quick look at evaluating polynomials. This will help you answer questions from exercise 6a. So let's have a look at this first example here. We can see we've got a polynomial function defined as x cubed minus 3x squared minus 2x plus 1. And again, the concept of a function is that for a given input x, p is found by this rule. Cube x, subtract 3 multiplied by the square of x, subtract 2 multiplied by x, and then add 1. So if you see this kind of notation here, p of negative 1, what it's really asking you to do is to substitute negative 1 for x to work out what p is, or to be precise, p of negative 1. It's a direct substitution. I tend to always want to write the substitution in, particularly when I've got negative numbers working. And you can see instead of having a lot of multiplication signs everywhere, I just put brackets around the thing I'm substituting in. And then I figure it out from there. Maybe in one step, like in my head, or now I'll do it in 2 steps because it's easier for the video. So negative 1 cubed, please remember that when you raise a negative number to an odd power, the answer is negative. And if you raise a negative number to an even power, the answer is positive. So I've got negative 1 cubed is negative 1. Negative 1 squared is positive 1 times by negative 3 is negative 3. I've got negative 2 times by negative 1, which is equal to positive 2. And then I've got my plus 1 at the end. And now I can simplify that to, well, I'd probably go negative 1 plus 1 cancels out to 0. So negative 3 plus 2 is equal to negative 1. So the evaluation of the rule at the point negative 1 is that p equals negative 1 as well. That's just a coincidence. Here we go. We've zoomed out so you can see the other options, as other examples we're going to go through too. In the second example, you're trying to find an unknown constant. So x is the independent variable. You can see it by the fact that it says p of x. Anything that's not x here is supposed to be a constant number, just a number we haven't worked out yet in the case of b. Okay, if it said p of b, then that would be completely different. It would mean that b is the variable and that for some reason this stuff here is supposed to be constant. Okay, so when I go p of 2 here, that means replace x with the value 2, not b. And I'm given something here. I'm told that p of 2 is equal to 10. So let's bring that all together. P of 2 is equal to 2 cubed plus 3 times 2 squared plus b, which I don't know, and that equals 10. One of the very few times when I'll put an equal sign on the same line, as you can see here. And now I'm going to kind of forget about this because this is the key thing that I'm interested in. I'm going to simplify this. I might just do it in a couple of steps, in one step here this time. 2 cubed is 8. 2 squared is 4 times 3 is 12. So I've got 12 here plus 8. So I've got 20 plus b is equal to 10. And now I'm going to take away 20 from both sides, like so, to leave me with b is equal to negative 10. Okay, putting it all together, i.e. p of x is equal to x cubed plus 3x squared minus 10. There you go. Example 3. This is from question 7 in the textbook. It is question 7 in the textbook. It's not too uncommon to have this kind of problem where you've got a polynomial on one side and a polynomial on the other one, but this one is partially factorized. And what we need to do is we need to find out what b and c is. And if you remember back to the last video, we said 2 polynomials are equivalent if the corresponding coefficients are the same. So let's see that in practice. I'm going to take the right-hand side, that's what RHS means, and I'm going to write it down and expand it. So you can use chicken beak method or box method, whatever floats your boat. Just because it's not that common to do the box method with 3 terms, I'm going to do it with 3 terms. I'm feeling crazy. X plus 1, x squared plus bx plus c, and let's fill in the boxes. X cubed, bx squared, cx, x squared, bx, and c. And now we're going to do what we normally do, and that is add along the diagonals in order to come up with an expression for each of the powers of x. So I'm going to do this in just a lightish kind of green, I think. So we've got an x cubed here, and then we've got an x squared along this diagonal. We've got x's along that diagonal, and we've got a constant here. So what does that mean? It means I've got an x cubed, and I've got 1x squared plus bx squared. So that's 1 plus b x squared. Yeah, just by adding the coefficients together, the bits before the squared term. This here, I've got bx plus cx. So that is, I'll just do it down here, b plus c x. And then finally, I've got a c. Okay, so that is the expansion of the right-hand side in powers of x. Now, do you remember what I said about equivalent coefficients? So we do a step called equating coefficients. I'll put it in this spot here. Equating coefficients. We look at, well, we don't have to worry about this, but the x cubed term has 1, and this x cubed term has 1. So that's okay. If they were different, we'd be in all sorts of bother. Let's have a look at the x squared term. In this part of the equation, it's minus 7. In this part of the equation, it's 1 plus b. And so therefore, 1 plus b must equal minus 7. Equating the x terms, we've got 4 for the coefficient of x here, and b plus c for the coefficient of x here. B plus c is equal to 4. And thirdly, we've got the constant term 12 here and the constant term here of c. So the third thing we can say is c equals 12. So we've equated the coefficients, and it's a pretty straightforward thing to work out what b and c is. I'll do that on slide 8. So I might even just number those different ones. Instead of numbering them 1, 2, or 3, I could number them x squared, x, and constant if you wanted to. So from 1, we've got 1 plus b equals negative 7, so b equals negative 8. From 3, we've got c equal to 12. Okay, so that's kind of done. But we can check in 2, and we have b plus c, so minus 8 plus 12 equals 4. Yes, it does. Okay, so that's all good. So that means that we now know what b and c is, which means that we can say, I'm going to be very squishy here, so I do apologize for the squishiness, but it means that x cubed plus, minus 7x squared plus 4x plus 12 is equal to x plus 1 multiplied by x squared plus bx, and we worked out that b is negative 8, so I can put minus 8x there, plus c, and we've worked out that c is 12, so it's plus 12, like so. Now, if you have a look at question 7 in the textbook, it then says factorize to 3 binomials or something like that, and so it's just a matter of taking the trinomial there and factorizing it. So, for example, I can see that negative 6 times negative 2 is 12, and negative 6 minus 2 is negative 8. You could use whatever technique you want to in order to get to the same conclusion, but there you go. X plus 1 times x minus 6 times x minus 2. So that's the trick there. It's called equating coefficients, and it's a very powerful technique in order to solve problems.